Hi, and welcome to your video tutorial for copper amine synthesis and UV-Vis spectroscopic analysis. We'll be working with your dilution techniques again as we prepare a set of standard solutions. We'll be adding a new skill, spectrophotometry, which will allow you to analyze the solutions which you've prepared. You will then compare the absorbance data that you get from the spectrophotometer to the concentrations which we will calculate to determine the relationship between them. Alright, so let's go over some safety tips real quick. As usual, you have to wear your goggles anytime chemicals are out. Today we'll be working with concentrated ammonia, which is a base with a strong odor, so make sure you keep it in the fume hood. Everyone will know if you bring it back to your lab bench. If you spill anything on your skin, flush it thoroughly with water. At the end of the lab, you can dispose of all the solutions by pouring them down the sink. Okay, so let's get started. During today's lab, you'll be synthesizing a complex ion called copper amine. So your first step will be to weigh out some copper sulfate pentahydrate accurately using the balance. Refer back to the earlier video on how to use a balance if you don't remember how. We recommend that you use some weighing paper to help you transfer the crystals to the volumetric flask. If you fold it from corner to corner like this, it'll form a nice little cup that'll hold the crystals in place while you measure, and then you can use it to form a spout to pour it into the flask. Make sure all the crystals actually make it into the flask. If you spill anything on the balance or lab bench and you don't clean it up, participation points will be deducted. Next, dissolve the copper sulfate pentahydrate into a small volume of water. You can swirl it around and hold it in a warm hand to help it dissolve faster. Once it has dissolved completely, you will have formed this complex ion. It should be a light blue in color. Now it's time to move to the hood so you can add the ammonia. Use the pipette to add drops of ammonia to your flask. It will turn a clear, dark blue, which indicates that copper amine has formed. Then add a little extra. Usually if you go up to this line, that'll be enough. If you don't add enough ammonia, a precipitate will form, your solution will turn cloudy, and it will remain light blue. After adding the ammonia, move back to your lab bench. Add water to the volumetric flask until the meniscus rests on the line. If you accidentally fill it past the meniscus, you will have to start over. Place the cap over the top of the flask, or if no caps are available, you can use parafilm, and invert several times to mix it. Once it is finished, pour your solution into a clean, dry beaker. Now your stock solution is finished and you're ready to start on the dilutions. In the physical properties lab, we made dilutions by taking a stock solution and then we took a small amount of volume from the stock solution each time to make our set of dilutions. So this lab's going to be a little bit different. So we're going to have our stock solution and we want to make our first dilution. So we're going to take a small volume from the stock solution and use it to make the first dilution. Now when it comes time to make the second dilution, you're going to take a small volume from the first dilution and add it to the second. And then you make the third dilution by taking a small volume from the second and adding it to the third. And so you keep going until you get a set of dilutions that kind of decrease in concentration. We're not going to go through the dilution technique again in this video, so if you're still unsure about your technique, go back to the physical properties lab video to review it. So just like in your physical properties lab, when we did these dilutions, we had to calculate the new concentrations, and we used that formula C1V1 equals C2V2. So for this lab, the same formula applies, except we're going to call it M1V1 equals M2V2, because we're adding a new concept here called molarity. In the physical properties lab, we measured concentration by weight, but a more useful way to measure it is in terms of how many atoms or molecules are dissolved in a given volume of your solution. So usually that number of atoms or molecules is huge, so it'll have like 20 zeros after it. So we want a simpler way that we can express that quantity. So we're going to use the mole. Now 1 mole is equal to 6.022 times 10 to the 23rd molecules or atoms. This is similar to the way that we say that 1 dozen is 12. So you can think of it like that. Now, when we go to look at how we use this to measure concentration, we're going to measure it in moles per liter, or molarity. In this lab, you will be preparing a stock solution which has a concentration of 0.02 molar. So you'll need to do some calculations to find out how much of the solid crystal you should dissolve to make this concentration. So Dr. March is going to run you through a few hints on how to get started with that.
Today we're going to try to give you some helpful hints on how to do your pre-lab calculation in terms of how many grams of copper sulfate pentahydrate you need to make your stock solution. Whenever we start a problem like this, we want to start with the easy thing. And the easy thing here would be to calculate the molar mass of the copper sulfate pentahydrate. The question always becomes, do I include the water? Well, if the water's in the crystal when you put it on the balance, then we've got to include the water. So copper sulfate pentahydrate, you're going to look that up, it's easy to find, and calculate the molar mass. The next part of the hint is to include the definition for molarity. Molarity is moles per liter, moles in the numerator, liters in the denominator. Moles of copper sulfate pentahydrate in the numerator. Now, we don't have 1 liter flask, we're going to have a 25 milliliter volumetric flask. And as we look at that 25 milliliter volumetric flask, we're going to use that volume and the molarity to get to the moles of copper that I need. So think about how the units will work to get to those moles of copper. Once I have the moles of copper, then I'm going to do moles to gram calculations. Moles to gram calculations are demonstrated in your textbook with a couple of different example problems. You should go looking for those example problems. With that, I think you'll be ready to go. Good luck.
Alright, so you've made your set of dilutions and you're ready to go use the spectrophotometer. So now we need to go down the hall to Chemistry 360 where the spectrophotometer is. Use a blank containing only water first. Clean 2 sides that are across from each other with a Chem wipe. Open the door and place the blank inside the spectrophotometer. Make sure the 2 clean sides are in line with the light source and the detector. Close the door. Move to the computer. Find the button that says 0 and push it. This negates the effect of the water molecules. The red absorbance value in the corner should be at or close to 0. Remove the blank. Clean one of the cuvettes that contains one of your dilution samples and place it inside the spectrophotometer. This time, select Read. The absorbance value is shown in the corner in red. Record the value in your notebook, then repeat the process with the rest of your solutions. You only have to zero it once. If you forget to write one down, the values will remain on the screen here. The spectrophotometer should be set at 560 nanometers. Ask your TA to fix it for you if it displays a different number. So your spectrophotometer is actually a super expensive light bulb. So you have a light source on one side, and we know how much light it emits. You've got your solution in the middle, and then we've got a detector which measures how much light makes it through. So we're going to shine a known amount of light through your solution. Some of the light is going to be absorbed by the solute molecules, and then some, whatever's left, is going to hit the detector. So by measuring the difference between what we shot through it and what made it to the detector, we can determine how much was absorbed by your solution. So if you look at the cloudy solution that it's possible to accidentally make in this lab, how would that affect its absorbance? Alright, if you think back to your physical properties lab, we made a set of dilutions, calculated their concentrations, measured the density, and used that data to make a graph of what the relationship was, so that we could use, if we had an unknown where we knew what the density was, we could maybe find what concentration it was. So with this lab, you'll be doing the exact same thing. You'll be using the data, both the concentrations that you calculate and the absorbance that you get from the spectrophotometer, to create another graph so that you could pick out, if you were given just an unknown solution, you could measure its absorbance to see what the concentration is. But you have to figure out what the relationship is. So it might be linear, it might be inverse, it might be logarithmic, or there might be no relationship at all. So it's your job to figure that out. Alright, so just to wrap it up, here are a few quick hints. So a lot of times the smaller dilutions will kind of look like they're the same color, so make sure you find a system to keep track of which is which. Your cuvette only needs to be clean on 2 sides, the side where the light goes in, the side where the light goes out, so you only need to clean those 2 sides. If you haven't seen molarity and moles before, it's okay, so just look in your book, look online, find some examples, there's tons out there, and learn how to do these. If you have any questions, you can make an appointment with your TA or ask one of your instructors. Alright, so that's all I have to say. Good luck in lab!